Tetris, one of the most classic and legendary games of all time. Invented in 1984 by Russian programmer Alexei, Tetris follows an incredibly simple rule set. Players rotate and place falling blocks called tetrominos to complete lines and prevent the stack from reaching the top. There are already so many wonderful videos and projects out there on using AI to beat Tetris, two topics I always wanted to do a project on. Then I remembered a game my friend showed me a few years ago. He called it Sandtris, and it's this neat game where the blocks break into particles upon the ground. Clearing is based on a span from left to right. So to code Sandtris, I would need to figure out Sand, which takes physics knowledge, and Tetris, which takes game development skills. Unfortunately, I have no experience with either. Luckily for me, the internet is a wonderful place, and chances are what you are looking for already exists. Thus, I'd like to give a huge thank you to EduCAS for your Sand engine. I tested it out and I really enjoyed the physics. Upon some analysis and studying, I learned that sand follows a pretty simple rule set. It flows left or right depending on what is available. Just following this creates these very nice spiky mounds that we can all see. I coated up some tetrominos and put the sand into them, so that when the tetromino breaks, it turns into sand particles. What's nice is the color gradient I got to work, which makes these really nice oopsies. Okay, I fixed the code to break upon contact with sand, and now it looks great. I made a quick playable version to test all the functions, and as we can all see, the features seem to be working super well. The physics are clean, and the clearing works. Oh, what's this? The title of the window says, "Subscribe to Pleth." Whoa! But on a more serious note, please take a moment to like this video and subscribe. This is my first ever attempt at a substantial coding project, and I really would love to snowball into a larger audience to keep showing off what I love doing. Back to the video now. The code even contains functionality for wall kicks, where rotation upon walls is allowed and the block's position is offset to fit in the play space. If you remember the starting clip, I rammed the I block into the wall and kept spinning it because I wanted to show off this mechanic. So this is the code. Now making it myself would be a nightmare, but say it with me now.
The internet is a wonderful place and chances are what you are looking for already exists.
Thus, I would like to give a huge thank you to Evan Zhao Dev, who has this great Tetris clone that has a very robust implementation of wall kicks. Another large change I made was to scoring. I decided to make it so that the more pixels cleared at a time, the more points you would get. This is meant to parallel how in Tetris, the more lines you clear at a time, the more points you get. Now we need to talk about the elephant in the room. Why AI? Well, it's obviously because it does really well on YouTube. Seriously though, this game does not have a core strategy or pattern to follow. Thus, I'm hoping AI might be able to make a discovery that shows off something I myself do not realize. I thus set out two goals for this project. I wanted the model to find out patterns to get high scores. If I could, I also wanted the AI to surpass the scores of human players. Before we dive into training, let me go over how this model works. The AI is a CNN, which is short for Convolutional Neural Network. In simple terms, it is good at analyzing 2D spatial relations, like the game space we have filled with sand. The algorithm we use to train this model is DQN learning, which is short for Deep Q Network. What that looks like is that the AI gets the state and makes actions. These actions get thrown into the magical machine called a Q function, which converts the actions into a numerical reward. The AI then learns if the move was good or bad, depending on whether the reward was positive or negative. This reward guides future decisions. With all of this out of the way now, let's check out my first playthrough to see how I perform as a baseline. I'll be speeding up a lot of the boring sections where nothing really happens, as there is a lot of that in the gameplay footage. So I ended up with a score of just over 60,000. I did not know if this was good or bad, as this was my first score I ever had with my cloned version. I then started my first training session and let it run overnight. Sorry about the voice, I just woke up and I'm checking this out before I start my day. So I let it run overnight and it definitely is doing something different now. It has a new strategy it appears to be implementing. I'll let this run out of training steps and I'll be back when it's done. I know it says generation 39 and only 4 hours in the sidebar, but it's been a couple days since I last checked up on it, and it's been training the whole time. To summarize version 1, it made it to about 750 generations in about 50 hours. It was trained over 500,000 steps and the average score was about 900. For its pros, it had a very high score, but for cons, it appeared to just be luck as the average score was pathetic. The reward function also got janky as I messed around with it a little and added too many parameters. For version 2, my goal was more steps and a better reward function. I'll see you again when version 2 is done. Version 2 just hit 5 million steps, which is where I set it to end. Pretty clearly, we can see a new strategy that emerged from the AI. For the 2,451 generations, version 2 took about 280 hours. With 5 million steps, it ended up with an average score of 6,700. For pros, it's still at a respectable high score, just short of 100,000. For cons, I felt like the average score could still be much higher. Thus, to fix it, I added even more steps and an even more robust reward function. For way too many times now in this video, I'll see you when generation 3 is done. Okay, it did something pretty spectacular here. We can watch it build a decent pile in the middle and then start trying to stack on the sides to consolidate the pixels into scoring. Version 3's 3000 generations took 480 hours. With 7 million training steps, it had an average score of about 10,750. The pros is that its high score was over 100,000 again and that it had a much better average. Also, in later generations, it consistently scored tens of thousands of points. Again, for cons, it could be a higher average score. Also, we saw in the end portion that it just started stacking really high in the middle, which is an issue regarding training data. To fix this, obviously, more training steps would help. However, I had two more glaring issues. First is money. I did all of this on an M2 MacBook Pro with 8GB of RAM. While I had access to MPS, my CPU, GPU, and RAM were sitting at near 100% for over a month. This gets me to my second issue. Time. I started this project in mid to late June. Luckily, I was busy during July, so my laptop was free to train. Unfortunately, as summer comes to an end, I must pick my work back up and Sandtris will have to wait. On a brighter note, for the original goals I set, I believe the AI did successfully discover patterns. For the other goal of outperforming humans, I would mark it as half successful. These two scores are from two of my friends who I had playtest the game. While the AI was either close to 100k or over it, it could not consistently pull this off. However, I was interested to see how good the pattern it discovered was, so I applied it in my game. What's cool is that the AI even figured out that bigger blocks means more score, as I watched it try to create large reservoirs of pixels before trying to score. But enough of me talking, let's watch me apply the AI strategy and make more intelligent decisions than it could. I am speechless. To recap, my first attempt was just over 60,000, while my friends were just under 60,000 and just over 100. The AI peaked at just over 100 and 140,000 respectively. My application of the AI strategy was 355,448 points, blowing every other result out of the water. In my opinion, this proves that if I had more money and time, the AI would have gotten significantly smarter. If you're interested in playing Sandtris yourself or tinkering with the AI, check out my GitHub repo for the project. There's a link in the description, and it contains installation instructions as well as my favorite quote for this project. If we get enough brains, we can go from a plethora of bees to a hive mind of brains. My name is Pleth, and I am so thankful to you for watching my first ever project video. Have a good day, and happy programming.